Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in short range wireless communication. We're going to see antenna characteristics. This video is going to be the continuation of the previous video, where in previous video we have seen basic antenna characteristics, and today we're going to see another set of antenna characteristics, that is we're going to see polarization, bandwidth and antenna factor. We will start with antenna polarization. When it comes to polarization, you ought to know what is antenna. Antenna is capable of radiating the electromagnetic waves. It can able to transmit and receive the electromagnetic waves. Right? When we say electromagnetic waves, you will understand that in electromagnetic waves we have both electric field and as well as magnetic field. And you can see this particular diagram where how the electric and magnetic field is oriented in EM waves. Right? Now, what is polarization? Polarization of the antenna is the direction of the electric field produced by the antenna. So, it is nothing but the direction of electric field produced by the antenna. And this direction of electric field determines the direction of transmission and reception of the antenna. I repeat that, like this direction of electric field determines the transmission and reception direction of the antenna, right? And this polarization of three different types, where we call it as linear polarization, circular polarization and elliptical polarization. When we say linear polarization, it can be of two different types. One is horizontal polarization and vertical polarization, which depends upon the plane in which the electric field radiates, right? And similarly, we have circular polarization, where the RF wave rotates in circular polarization, and this circular rotation can be either towards right side or left side, so that we can call it as RHCP or LHCP, which is right hand polarization or left hand polarization. Similarly, the wave can also rotate elliptically. That is called as elliptical polarization, right? So polarization is nothing but the direction of electric field produced by the antenna. So with this basic of polarization, we see in depth about what is linear polarization, what is circular and what is elliptical polarization, right? And as I said, an electromagnetic waves is composed of both magnetic field and as well as electric field. And when it comes to direction of polarization, the direction of polarization depends upon the direction of the electric field produced by the antenna. And this direction of electric field is related to the earth. And similarly, as I said, this polarization can be of three different types: linear, elliptical and circular polarization. Very normally used linear polarization, where we have horizontally polarized and vertically polarized, depending upon how the electric field is radiated, right? And you can see here a plain wire parallel to the earth is called as horizontally polarized, and a wire that is normal to the earth is vertically polarized. And what is elliptical polarization? The electric and magnetic field may rotate in their plane, and this is created by feeding the RF signal on the RF communicating frequency that are not in same phase, right? That are not in the same phase with each other. And similarly, circular polarization is created by RF signals which differ by 90 degree, right? And elliptical antenna is capable of producing both elliptical and circular polarization without having two different points. And when it comes to polarization, you understand that the horizontally polarized and vertically polarized cannot be, like, for example, if you want to have better results, right, the horizontally polarized antenna has to receive the horizontal polarized wave. It cannot able to receive the vertical polarized wave. Then the result will be very poor, right? That is, a dipole, a horizontal dipole can able to generate horizontal horizontally polarized wave. Similarly, a vertical dipole can create a vertical polarized wave, right? When it comes to transmission and reception, an horizontally polarized antenna, right, will produce poor result when it receives the vertical polarized wave, right, and it is vice versa. So for a better result, right, for any particular transmission, right, if we can able to receive an horizontal polarized wave with horizontal antenna, polarized antenna, then the result will be better, right? But the polarized wave while transmitting, there are chances that it can able to change the direction because of the ionospheric effects, right? Two types of elliptical polarization, that is, as I said, right hand and as well as left hand, depending upon the rotation of the electric field. And the polarization of a wave or antenna is important for several reasons. That is, horizontal polarized receive antenna cannot receive vertically polarized antenna, as I said before. And similarly, when we say horizontal and vertical polarized antenna is not compatible, similarly the circular right hand antenna and similarly left hand circular polarized antenna is not compatible, right? And for any particular transmission, that is line of sight or directional transmission, polarity of propagation will not change, but there are chances that because of distortions, because of ionospheric effect, the direction may change. There is one important factor which is called as cross polarization. It speaks about the degree. We said that the horizontal polarized wave, right, cannot be received by a vertical polarized antenna. That is, it will receive, but the result will be very poor, right? But that ability of an antenna to receive an opposite polarized wave, that is called as cross polarization. You can see that the cross polarization is defines the degree to which the transmission from an antenna of one polarization can be received by the antenna of opposite polarization, right? The polarization of a transmitter and receiver is not well defined, such as in case of handheld devices. A circular polarized antenna can be used when the opposite polarization is not known, right? Cross polarization between antenna results in signal attenuation, and we already said what is cross polarization. It is an ability of an antenna to receive the opposite polarized wave, right? And next important factor is bandwidth. What is bandwidth? Bandwidth is the range of frequency over which an antenna can operate, right? You can see the antenna bandwidth is the range of frequency over which the antenna can operate, while some other characteristics remains within a different defined range, right? And it is related to antenna impedance. And whenever we say an antenna with wider bandwidth or narrow bandwidth or high Q antenna, right? High Q antenna, that is antenna with high Q antenna, very narrow bandwidth, will discriminate the unwanted harmonics and spurious radiation, right? So that is, it will suppress, it will reduce the harmonics and as well as the spurious radiation, which will also reduce the requirement of supplementary filter. Whenever there is no limited harmonics, whenever there is very less harmonics or very less spurious radiation, then we don't need filter to eliminate those unwanted signals, right? And another important factor is antenna factor. Antenna factor is the ratio between the electric field, the incident electric field, and as well as the received power, right? You can see here it is related to the field strength to the voltage across the antenna terminals, right? So that is AF is equal to E by V. So it relates the field strength to the voltage across the terminal, and it can also be defined as AF is equal to 20 log E by V. So the amount of wave, that is incident wave, to the voltage that is received by this receiver antenna, right? And it is commonly used for calibrating the test antenna to make field strength measurements on test receiver or spectrum analyzer, right? And AF is the antenna factor per M, and E is the field strength, which is V by M. V is the load voltage V, right? And these are the important antenna characteristics which we have seen in two videos, in previous videos and as well as in this video. In previous video we have seen what is antenna impedance, that is It is combines of three parts, that is radiation resistance, loss resistance, and reactance, where we can mention antenna efficiency like this. And we have spoke about what is directivity and gain, effective area, and then polarization in this particular video, bandwidth, and antenna factor. All these are very important characteristics of the antenna. I believe this video will be very useful for you. Thank you, my dear students.